Welcome to lab number 7. Today's experimental topic is Bernoulli's analysis. The equipment used in this experiment are the Armfield H110 hydraulic bench and the Armfield F115 Bernoulli's theorem demonstrator. F110 hydraulic bench is used to assist in flow demonstration. It has a pump and a reservoir that stores water. The F110 also has a quick release connector to facilitate benchtop apparatus. There's also a volumetric tank, which you can see, that has a bed tapping that allows readings in liters. The flow rate can be calculated by using these measurements in liters along with a stopwatch to observe how many liters the tank acquires over a particular time. The F115 Bernoulli's demonstrator has a series of wall tappings that enables measurements of static pressure distributed along the conversion and diversion duct. A total head tube is provided to traverse to take readings at the different tappings. This is done so by releasing this screw and adjusting the tube, which gives us total head readings, to the tapping of which you are taking readings from. These tapping, along with the total head probe, are all connected to a manometer bank, incorporating a manifold at the top with an air bleeding valve to remove air pockets in the system. The manometers are notated as H1, H2, H3, H4, H5, H6, H7, and H8. Before starting the experiment, we must observe that the H115 is leveled. This is done so by adjusting these legs. We should also ensure that the test section has a 14-degree tapered section converging in the direction of the flow, as this section can be reversed for a different experiment. Now that our system is leveled, we would then turn the pump on, turn all the valves on, and allow for the system to remove all the air pockets. So as you can see, air bubbles are being removed from the system. We will wait until the system is purged for us to begin the experiment. At this point, we would remove the bleed hose. Then we would open the air bleed screw to reduce the manometer levels to midway on the chart. This will allow us to have sufficient reading while flow is present. After removing all the air pockets, we would observe that at no flow, all manometer levels should be the same. This indicates that the system is ready to go. The manometer readings are all in millimeters. So all our H1 to H8 readings are in millimeters. Now that the equipment is ready, what we will be doing today, we are going to be observing H1 readings from 1 to 6. That's our static pressures. And then we're going to also observe H8, which will be our total head probe, which can be adjusted. As you can see, the probe moving inside. So we would adjust the probe to each reading H1, H2, H3, H4, H5, and H6. The experiment will be done 3 times at 3 different flow rates. In each flow rate, we'll observe H1 to H6 along with H8. Our flow rate will be adjusted by closing the gate valve on the F115 and also on the F110. The flow rate will be observed by releasing this ball valve to allow water to the volumetric bench, from which we would use a stopwatch to measure our liters acquired in the volumetric tank against the time it takes. That we'll do 3 times to acquire 3 different flow rates. Now we're ready to begin the experiment. So we're going to turn the pump on and adjust our flow rate to a high flow rate. So, as you can observe, our H1 reading is pretty high, and our lowest reading, which is H5, is pretty low. While doing the experiment, we need all manometer levels to stay within the chart. So I will not apply any more flow because I need the manometer to be within the chart, both for the highest and the lowest. Now what we would do from here is to release our ball valve so we can start water in the bench. We would then start our stopwatch when we get to 0, and we would observe the volume of water over a time period no less than 60 seconds. I'm going to allow go up to 10 liters. Whatever amount of seconds it takes to get there, I'll stop. So that was 10 liters at 1 minute 12 seconds. Now that we have acquired our flow rate, what we would do next is to take readings of H1 to H6. So H1, we are at roughly 275. H2, we are at 230, 235. H3, we are at 194. H4, we are at 152. And H5, we are at 99. And H6, we are at 164. Next, what we would do is to adjust our probe to H1, which would give us our total head reading 275. Then we would adjust our probe to H2, give the system some time, then take readings again for H8, and we're at 275. We would then adjust our probe to H3, take readings 275. Then we adjust our probe again to H4, take readings 275, and then adjust our probe to H5, take readings 274, and finally adjust our probe to H6, take readings. It's going down, so we have to give it some time to stabilize. So now it's at 185. So that would complete our first set of data readings at the high flow rate. Next, we would decrease the flow by turning the valves down in a clockwise position. As you can see, the manometer levels are moving. Then we would repeat the volumetric tank measurement process with the stopwatch. After that is completed, we would go ahead and take H1, H2, H3, H4, H5, and H6 tapping reading. Then we'll go ahead and adjust our probe again, taking total head readings for H1, H2, H3, H4, H5, and H6. Finally, we would go ahead and adjust our valve again to a lower flow rate, and as you can see, the levels on the manometer are coming down. And once our system is stable again, we would go ahead and adjust our ball valve and do our volumetric tank reading with a stopwatch again. Then finally, we would take static readings from the top, H1 through to H6. Then we'll adjust our probe again from H1 through to H6. That would then leave us with 3 sets of data reading, 1 at a high flow rate, 2 at a mid flow rate, and finally at a lower flow rate. Now at this point the experiment is over. We have gathered all the data we need. If you have any questions or concern, feel free to contact your professor, Dr. Whitworth. Thank you.